Welcome to Section 4 of the Value Stream Mapping VSM program by Advanced Innovation Group. In this section, we'll continue our deep dive into how VSM helps identify waste, visualize process flow, and improve value delivery across operations. Let's explore how data-driven mapping connects people, processes, and technology to create a leaner, more efficient system. Welcome to the section on Designing the Future State Map Part 1. In this module, we'll begin exploring how to envision an improved version of the process by identifying ideal flow, removing waste, and aligning operations with customer value. This section sets the stage for creating an actionable future state that drives real transformation. In this section, we focus on designing the future state map. Our goal is to create a to-be process that achieves flow, pull, and a balanced workload. We'll use insights from the current state map, especially wastes and bottlenecks, as key inputs. By the end, we'll have a future state VSM along with a practical implementation plan to guide process improvements. The purpose of creating a future state map is to visualize a leaner and more efficient process. We aim to eliminate waste and non-value-added steps, improve flow to cut down lead time, and align all activities to talk time for synchronized operations. Finally, we establish visual controls and pull mechanisms to ensure continuous and demand-driven flow. When designing the future state map, we rely on guiding questions to shape improvement. We start by asking, what does the customer really need? This defines our talk time. Next, we identify where the flow should be continuous, where pull loops or supermarkets are required, and how to level production using Heijunka. These questions help ensure the future state design aligns perfectly with customer demand and process efficiency. The next set of guiding questions focuses on building quality, flow, and sustainability into the future state design. We ask, where can we build quality at the source? And how should the information flow triggers work? Then, we determine how many operators and resources are required to support the process efficiently. Finally, we define how to measure performance and sustain the improvements over time to ensure long-term success. The first principle in designing a future state map is flow where possible. We aim to remove waiting and batching to move toward one-piece flow. Steps should be co-located in a logical sequence like a U-cell to enhance efficiency. Wherever possible, automate handoffs and approvals and cross-train operators to create flexible, multi-skilled teams that can maintain continuous flow. The second principle is pull where necessary, meaning we produce only when there is actual demand. We use Kanban cards or digital signals to trigger replenishment instead of pushing excess inventory. By limiting work in progress through supermarkets or FIFO lanes, we maintain smooth flow. We also define minimum and maximum inventory levels and set replenishment intervals to avoid overproduction and ensure material availability when needed. The third principle is level workload, also known as Heijunka. The goal is to smooth out variations in volume and mix to prevent work spikes and idle time. We can use a Heijunka box or digital scheduler to plan production evenly. Focus on smaller, frequent batches instead of large ones and ensure that the production or service rhythm aligns with talked time to maintain steady flow and efficiency. The fourth principle is build quality in, ensuring that quality is created at the source, not inspected at the end. We use Poka-yoke techniques to prevent errors and rely on 100% visual checks or automated validation. Our goal is a first-pass yield above 98%, meaning work is done right the first time. Finally, we establish an immediate feedback loop so defects are detected and corrected instantly, ensuring continuous improvement. The fifth principle is synchronize information flow, ensuring data moves as smoothly as materials. We aim for real-time signals to avoid delays from manual reports. Dashboards and SLA monitors provide instant visibility into performance. Automated approvals should trigger the next step seamlessly. Finally, by integrating systems, we reduce dependency on emails and ensure faster, error-free communication across teams. When designing the future state map, we must carry forward key performance metrics from the current state. Here, we're targeting major improvements, reducing lead time from 5.2 days to less than a day, increasing value-added work from just 0.03% to over 5%, cutting down WIP before assembly from 1,200 pieces to under 100, and improving first-pass yield from 89% to above 97%. These targets will guide our design decisions for the future state. When designing the future state map, we apply improvements differently for manufacturing and service processes. In manufacturing, we convert batch production into one-piece flow or pitch-based lots and add FIFO lanes or supermarkets between cells to manage flow. For service processes, queues are converted into caseable systems based on priority, and digital workflows or chatbot triggers are introduced to improve response time and automation.